In this fourth midterm review, I'm going to be going over everything with coordinate geometry, but not quadrilaterals. So there will be no quadrilateral coordinate proofs on the midterm. So for number one, the endpoints of one side of a regular pentagon. So when it's a regular polygon, that means all sides are congruent. When it's a pentagon, that means there are 5 of them. So the endpoints of one side are -1, 4, and 2, 3. What is the perimeter of the pentagon? So remember, to find the perimeter, you need to add up all the sides. So what I'm going to do is I'm going to plug into the distance formula, which, if you don't remember, is x2 minus x1 squared plus y2 minus y1 squared, all under a radical. And that's going to give me the length of one of the sides if I find the distance between those 2 points they gave me. So I'm just going to substitute into that formula. x2 is 2, minus -1 is just plus 1, plus y2 is 3, minus y1 is 4. And if you plug all that into your calculator, you'll find that that inside is just 10. So the distance for one side is radical 10, but remember that you're looking for the perimeter, and there are 5 sides to the pentagon. So it should look something like this, where it's a pentagon, and there are 5 sides that are all radical 10 and all the same length. So if you add all those up, you'll get 5 radical 10. For number 2, line segment NY has endpoints -11, 5 and 5, -7. What is the equation of the perpendicular bisector of NY? Well, for the perpendicular bisector, you need 2 things. In order for it to be perpendicular, you need to have a negative reciprocal slope. And to be a bisector, it needs to cut it in half. So you need to know what the midpoint is, because it's going to go straight through the midpoint. So the first thing I'm going to do is I'm going to plug into the midpoint formula. Remember, that's just the average of the x's, comma the average of the y's. So I'm going to add up my coordinates and divide by 2. So for the x coordinates, that's going to be -11 plus 5 over 2. And for the y coordinates, it's going to be 5 plus -7 is just -7 divided by 2. -11 plus 5 is -6, divided by 2 is -3, and 5 minus 7 is -2, divided by 2 is -1. So that's the midpoint. That's a point that I know is definitely on my line. Now what I'm also going to find is the slope between n and m. If you don't remember the slope formula, remember that's just the change in the y's divided by the change in the x's. So in our case, y2 is -7 minus 5 divided by 5 minus -11 just becomes plus 11. So when I do that, -7 minus 5 is just -12, and 5 plus 11 is 16. When I reduce this slope, I end up just getting -3 over 4. But remember, you want the slope that is perpendicular to that. So I'm going to flip that and negate it. So here are the important pieces I need. I found the perpendicular slope, and I found the midpoint of that guy NY. So this line that I'm going to have is going to go through that midpoint, and it's going to have that slope. So I'm going to plug into point slope form of a line, which is y minus y1 equals m times x minus x1. And all these formulas that I'm pulling out here, you're going to need to remember for the midterm. So it's called point slope because all you need is a slope and any point on the line to write the equation. So y minus y1, in this case y1 is just that -1 from my midpoint, equals my slope, 4/3, times x minus x1. When I subtract -3, it just becomes +3. So this is the formula of the line that is perpendicular to NY and that goes through the midpoint of NY. So my final answer is just answer choice 1. For number 3, which equations represent the line? That should just say equation. represents the line that passes through the point negative 2, 2, and is parallel, remember that just means it has the same slope, as y equals 1/2 x plus 8. Well, first off, I could rule out 2 and 4 because they don't have a slope of 1/2. Remember, the slope is that number that's being multiplied to x there. And if it needs to go through the point negative 2, 2, you've got two options. You could try substituting in this point into x and y to see if it makes the equation true. Or you could just set up the equation in point slope form. Something like this. So what I'm going to do is I'm going to rearrange this equation so it says y equals. So I'm going to distribute that 1/2 to get 1/2 x. 1/2 times 2 is just 1. And I'm going to add 2 to both sides so that I have isolated y to get 1/2 x plus 3, which I note is the exact same as answer choice 3. Again, if you wanted to substitute this in for x and y to see which one it makes true, that's also a good idea once you've ruled out answer choice 2 and 4. For number 4, which is an equation of a line that is perpendicular to the line whose equation is this and passes through negative 6, 1? Well, if y isn't isolated, it doesn't help me too much, so I'm going to start just by dividing out that 2 so that I can see that my slope is 3/2 and my y-intercept is negative 5. So if I need it to be perpendicular to this line, it needs to have a negative reciprocal slope to 3/2, which is just negative 2/3. And it also needs to go through the point negative 6, 1. So I'm just going to plug into point slope form to figure out what this equation should be. So y minus y1 equals my slope times x minus x1. Again, minus a negative 6 is just plus 6. I'm going to distribute that negative 2/3. Negative 2/3 times x is just negative 2/3 x. And if you're not sure what negative 2/3 times 6 is, you could always just plug that straight into your calculator. It's negative 4. So if I add 1 to both sides to isolate y, I'm just left with y equals negative 2/3 x minus 3. So I get answer choice 2. For number 5, in the diagram below, triangle ABC has vertices A, B, and C. What is the slope of the altitude drawn from A to BC? Well, remember that the altitude has to be perpendicular to BC. So if I know the slope of BC, I can just find the negative reciprocal. So here I'm actually just going to count because they gave it to me on a coordinate grid. So I go 1, 2, 2 up, and 1, 2, 3, 4, 5 over. So my slope of BC is just my change in y divided by my change in x, which means my slope perpendicular to BC is just the negative reciprocal, negative 5 over 2. Number 6, the accompanying diagram shows 2 cables of equal length supporting a pole. Both cables are 14 meters long, and they are anchored to points in ground that are 14 meters apart. What is the exact height of the pole? All right, so this to me looks like a Pythagorean theorem problem. I've got a right triangle right here. The hypotenuse is 14. However, if you recognize that this is an isosceles triangle, that altitude is also going to be the median. So both of these pieces are going to be 7. So if I'm plugging into that Pythagorean theorem, a squared plus b squared equals c squared, one of my legs is 7, one of my legs I don't know, and my hypotenuse is 14 squared. So 7 squared is just 49, plus x squared equals 196. I'm going to isolate x squared by subtracting 49 on both sides, and I get x squared equals 147. So I notice all of my answers seem to be simplified a little bit here. So I'm looking at radical 147, and I'm thinking, what could I break it up into so that one thing is a perfect square and one thing isn't? Well, you could try a couple numbers in your calculator, but if you divide 147 by 3, you get 49, which is a perfect square. So I'm going to break up 147 into radical 49 times radical 3. Radical 49 simplifies to 7 radical 3, so my answer choice is 3. What are the coordinates of a center of a circle if the endpoints of the diameter are 8, negative 4, and negative 3, 2? Well, think about a circle, right? It's got a center, and let's say you've got, doesn't matter where these points are, let's say A is over here, B is over here. This is obviously not drawn to scale, but I've got a chord that goes through the center of my circle here, and I want to know where the diameter, or where the center of the circle is, rather. Well, remember, a diameter is just made up of two radii that are connected to form a straight piece there. So if I find the midpoint of AB, I'd be done. So I'm just going to average the x's and average the y's. 8 minus 3 is 5. 5 over 2 is 2.5. Negative 4 plus 2 is negative 2. Divided by 2 is negative 1. Number 2. Number 8. Two lines are represented by those two equations. For which value of m will the lines be parallel? Remember, parallel lines have the same slope, but I need to have y isolated here so that I could see what the slope is. So I'm going to multiply everything by negative 2. The reason I do that is because negative 2 times negative 1/2 is just 1. So I'm left with y on the left-hand side there. Now, negative 2 times 6 is negative 12x, and negative 2 times 10 is negative 20. The reason this is helpful is because now I could see pretty easily that the slope is just negative 12. Had I been looking for a perpendicular slope, it would just be 1 over 12, or the negative reciprocal. Triangle PQR has vertices negative 3, negative 1, negative 1, 7, and 3, 3. Points A and B are the midpoints of PQ and RQ respectively. Use coordinate geometry to prove that AB is parallel to PR and is half the length of PR. So the first thing we need to take a look at is what are the midpoints of PQ and QR. So I'm just going to organize my work by finding some midpoints up here. I'll start with PQ. Now, you could do this based off of the graph because it actually does work out to be a nice number. But I am going to, right here, just average the x's and average the y's. So I find that my midpoint, or what they tell me A should be the midpoint of PQ, to be negative 2, 3. When I'm finding the midpoint of QR, I do the same thing. I average my x's, and I average my y's, and I find B to be 1, 5. So I'm going to plot those in my picture just to see if they make sense. So negative 2, 3 would be right up there. That looks pretty good for A. And B is supposed to be at 1, 5. Actually, that looks pretty good. And I'm going to connect them. Notice I am using a straight edge, because that's going to make finding the midpoints easier, looking for parallel lines easier. Okay, so the first thing I need to do is prove that AB is parallel to PR. Well, how do I prove the two things are parallel? I prove that they have the same slope. So that's what I'm going to do here. I'm going to find the slope of AB. So that's 5 minus 3 over 1 plus 2, which is 2/3. Now, if these are in fact parallel, I should get 2/3 when I find the slope of PR. And it ends up that I do. 3 plus 1 over 3 plus 3 equals 4 over 6, which does reduce to 2/3. So it is true that AB is parallel to PR because they have the same slope. So that's the first part. The second part that they asked me for is to show that PR, or that, that AB is half the length of PR. So if I'm asking to prove things about length in coordinate geometry, that's when I'm going to reach for the distance formula that we used earlier. So I'm going to start by finding the distance for AB. So I'm going to subtract my x's and square them, plus the subtraction of my y's and square them. So you could plug this all into your calculator. I don't recommend doing it piece by piece because it's a lot to take in. Okay, 1 plus 2 is 3, 3 squared is 9, 5 minus 3 is 2, 2 squared is 4. So this is just radical 13, which doesn't help us because we can't simplify it too much. And if I'm finding the slope, or excuse me, the distance between P and R, that's also a little tough because when I go into the distance formula and do my x2 minus x1 squared plus y2, 3 plus 3 is 6, 6 squared is 36, and 3 plus 1 is 4, 4 squared is 16. So when I add those, I find my distance to be 52. So let's take a look at these two over here. My distance for AB is radical 13, and my distance for PR is radical 52. Now these might not look like they have any relationship yet, but you need to simplify 52 and then it's a little bit more obvious. So you could break 52 into 4 and 13. So the distance between P and R is actually 2 radical 13. Now notice the relationship between them. If I take half of 2 radical 13, I get radical 13. If I double radical 13, I get 2 radical 13. So this is enough math to prove that AB is in fact 1/2 the length of PR. Triangle Dan has those coordinates. Using coordinate geometry, prove that Dan is a right triangle. Well, in order to prove that something's a right triangle, I'm going to need to, at some point, assert that it has one right angle. So the way I'm going to do this is by using the slopes and looking for perpendicular lines. So I sketched the picture to see that DA looks like it could be perpendicular to NA, so I'm going to try to show that here using my slope formula. So I'm going to subtract y2 minus y1 over x2 minus x1. I get negative 3/6, which simplifies to negative 1/2. So if this is perpendicular to NA, I'm going to want to get 2 for my slope for NA. So let's see what happens. 1 minus 5 over negative 4 plus 2 is equal to negative 4 over negative 2, which, lo and behold, simplifies to positive 2. And these right here are negative reciprocal slopes. Now that's good news, because that's enough to say that DA is perpendicular to NA, which in itself is enough to say that A is a right angle. Why is that? That's because perpendicular lines form right angles, which is enough to say triangle DAN is a right triangle, because right triangles have one right angle. Number 11. A circle has a center located at negative 2, 4, and has a radius of 10. So every point on the circle is 10 units away from negative 2, 4. Does the point 6, negative 2 lie on the circle? Well, if it does, it would have to be 10 units away from the center. So what I'm going to do is I'm going to plug into the distance formula to see if it is in fact 10 units away from the center. So I'm going to do x minus x, so I'm subtracting my two x values. It doesn't actually matter what order you subtract them in as long as you're consistent. 4 plus 2. And when I simplify what's in those parentheses, I get 100. And radical 100 is 10. Yes, it does lie on the circle. Why? Because the circle has a radius of 10, which means all the points in the circle are 10 units away. And by the distance formula, 6, negative 2 is 10 units away from negative 2, 4. I implore you to try number 12 on your own, which is a very similar problem, and check your work in the answer key. Number 13. Determine an equation for the line parallel to M, shown below, and passing through the point negative 2, 4. Well, we've done a lot with the slope formula already. I'm going to be a little bit lazy here, and I'm actually going to find the slope just by looking at two nice points on the graph. So between these 2 points, I can go up 2 and right 1, 2, 3, 4, 5. So the slope of this line is 2 over 5, my change in y over my change in x. So this must be my slope of the line parallel to it. If it needs to go through -2, 4, I could plug that into my point slope form, which again, remember, is y minus y1 equals m times x minus x1. I leave y as y minus my y1 equals my slope times x. When I subtract -2, it becomes positive. Now, it doesn't say to put it in slope-intercept form. So I'm not going to here because that would be more work and it just creates more room for error. So I'm going to leave it in point-slope form because that is perfectly acceptable as the equation of a line. But if you did end up distributing it and isolating y, it would look something like that. Number 14, write the equation of the perpendicular bisector between each of the given points. So I'm actually just going to do A because they're the same process. Again, it's two parts, perpendicular, bisector. For perpendicular parts, I need the slope so I can take the negative reciprocal. And to find the bisector, I need the midpoint so that I can plug that into point slope form because I know that's a point on my line. I'm going to start by finding the slope between these 2 points. y2 minus y1 over x2 minus x1. And this slope simplifies to -1. Now to find the negative reciprocal of -1, it's kind of the same thing as -1 over 1, so when I negate that and flip it, it just becomes +1. When I find the midpoint, I average the x's, and I average the y's, so my midpoint is just 2, 5. Again, I'm going to plug straight into point slope form with my x1 and my y1 as that 2 and 5. So y minus 5 equals my slope times x minus x1, which is 2. Again, you could rearrange this if you really want to, and you get y equals x plus 3, but there's no reason to because they did not ask us for it. Number 15. Find the altitude of an isosceles triangle that has legs with length 17 and a base of 24. They're talking about a triangle, so it's in my best interest to sketch it. It's got 2 congruent legs that are both 17 in length, and a base that's 24 long. Now the good news is about the altitude and the median and the angle bisector of an isosceles triangle is that they're all the same. So this altitude actually cuts the base into 2 congruent parts. So this is again one of those problems where I'm missing one of the legs of my right triangle. Remember, an altitude is perpendicular to the base. So I can set up another Pythagorean formula, a squared plus b squared equals c squared. I've got one of my legs, I'm missing one of my legs, and I have the hypotenuse. 12 squared is 144, 17 squared is 289. I don't expect you to know all those off the top of your head. You could plug those in. And when I isolate x squared, I get radical 145, just 145. And then to undo the squared, I take the square root on both sides. Now, the good news is you can't actually simplify 145. It doesn't break down into anything. So this is as far as we can go for this example. But for example 16, I now need to find the altitude of an equilateral triangle. Remember, for an equilateral triangle, all sides are congruent. So all sides are of length 16 here. So when I'm looking for this altitude, it still breaks my base into 2 congruent parts, 8 and 8. And I'm still looking for x. But now it says to find it in simplest radical form. So I know I will need to simplify at some point. So again, I'm missing one of my legs, but I have my hypotenuse. So 64 plus x squared equals 256. When I subtract 64 on both sides, I get x squared equals 192. I take a square root and I get x equals. Now is when I try to simplify. You could play around with a few numbers. You could always go into your calculator and do that trick where you do 192 divided by x and plug that into y equals, and then go to the table. That's a quick way to find factors if you're stuck and it's a bigger number. But it breaks down into 64 and 3. Radical 64 is 8, 3. So my altitude is just 8 radical 3. They don't give me any units, so I don't need to put any units on this one.